Hello guys again. This is Lecture-1 Part-2. In this lecture we will discuss about formation of oil and gas. There are some basic processes that should be understood to visualize the formation of oil and gas. Okay, let's observe this diagram where you can see sediments and their deposition at the bottom. During millions of years, these sediments mostly deposited under the marine or under non-marine conditions as well. And during this period, if some plants or some other organism also deposited with this material and they observed high temperature and pressure, these plants actually converted into oil and gas. These tiny organisms are commonly called plankton. Actually, these are from North Sea in Europe. So, a typical terminology for these organisms used there. Okay, when they converted into oil and gas, and then ultimately this oil and gas that is in black shape, you can see it moves upward because it's lighter than water, and now it's moving up and going to find any trap where it can accumulate. Organic sediments contain large amounts of the elements hydrogen and carbon, which are important constituents of oil and gas. As the sediments containing a lot of organic material are buried and heated, oil and gas are formed and liberated. The oil and gas are lighter than water, so they rise toward the surface. You can observe in this diagram. And here the typical value of temperature is also mentioned here. That is 120 centigrade. At this temperature, mostly oil and gas form in the subsurface. Okay. The first substance formed during the breakdown of organic material, such as plankton or any other organism, and that breakdown material is called kerogen. Kerogen is very important terminology. It is used for converted form of organic material. And kerogen is a wax-like substance that consists of large complex hydrocarbon molecules. Okay. And that kerogen actually required a particular range of temperature for converting into oil or gas. As you can see in this diagram, the highlighted temperature range is 150 and up is around up to 75. Actually, this temperature range is for oil window. If your buried organisms observe this range of temperature, they will ultimately convert it into oil, or the organic material that formed from those organisms will generate oil in this temperature range. Similarly, if the temperature range change or rise, as you can see here, from more than 200, starting from 150 to 225. In this range, mostly organic material produces gas. That's why it is called the gas window. So you should keep in mind the temperature ranges for your organic material so that you can interpret or you can assess what type of hydrocarbon, either oil will be produced in the subsurface or gas will be produced in the subsurface. That can be interpreted based on temperature data. If you drill a hole here, record the temperature in that hole and plot that temperature on graph and interpret it and uh, finalize the what's the range in the subsurface. So based on that range of temperature, you can define that where oil and gas exist in the subsurface. Okay, here is a typical, you can say, model for oil or gas saturated sandstone reservoir in below, and in black it is the shale. Here shale is acting as a seal. Seal means it's not permitting the oil and gas to leak from this sandstone reservoir. And this between the pores, this is oil or gas, both can be present here. And the arrows below shows that this oil actually migrated from the source rock. There, that is also the shale that may be deposited at the bottom of this model. And this oil is coming from that source. And this is a particular, you can say, model for visualization so that you can visualize where this oil and gas exist in the sandstone. It is in the pores, and if these pores are interconnected, then it can move. And one other thing that you can observe in this figure, that the comparison of shale and sandstone rock. As you can observe in shale, you can't see enough pores as well as the interconnection of pores. You can say very minimum or near to zero porosity for shale. But in sandstone reservoir, there's a good porosity there, and also some permeability also present in this sandstone reservoir. So, for a reservoir rock, it is necessary that it should contain porosity and permeability. And for source and seal rock, it is not necessary that it should contain porosity or permeability. Okay, okay. Here is a typical example for saturated sandstone reservoir, as you can observe in the middle of this diagram, which is filled with light red color, and also you can see a shale layer at the top of that sandstone reservoir that actually providing the seal to that reservoir. And you can also observe the shale at the bottom of this diagram in dark light dark black, and that actually is acting as a source rock in this area. And you can see the multiple layers are there, and the oil has migrated from the bottom up to the surface until it face the seal that actually mm, create a trap, or you can say this shale layer is not allowing that oil for further migration or further traveling to the surface. Now, this is a typical example for multi layers where the reservoir rock exists. Here, further distribution in the reservoir, both oil and gas can exist. As you can see, oil is low, gas is lighter than oil, so that it will take the upper part of the reservoir, and oil is heavier, so it will take the lower part, and further water is heavier than oil, so water will be at the bottom. And this is a typical, you can say, arrangement in the reservoir of hydrocarbon and water. Similarly, one example of leakage, how this petroleum or oil and gas can be leaked. As you can see, this is the fault line, these red arrows downward and upward, we are showing some fault plane, and along this fault plane, if some reservoir is there, oil and gas can travel along this fault plane, means they can leak from this reservoir. So these structures are also important, and we will look in detail in these structures, and we'll see how these structure can be beneficial or how these structures are bad for a good reservoir. And if all the oil and gas that has ever formed at depth were trapped by impermeable rocks, we would have enormous oil and gas field around the planet. However, a lot of oil and gas has escaped through cracks and faults in otherwise compact rocks as shown in the animation above or in the figure above. You can see there are a lot of examples in the world where the oil and gas is there, but you can't find any oil and gas because it was leaked due to these fault structures. Okay, let's see another example of source rock, reservoir rock, and roof rock. Similarly, the shale layer is a roof, or we can also say seal rock. And under the seal rock, there is a reservoir rock. This is sandstone, and it is filled with oil and gas. And at the bottom, dark black, that is the source. That is also the shale. That's actually the charging the layers, because oil actually formed in these source rock and then travel upward until it faces this seal rock or roof rock. Okay, here is another example just to give you some idea that these traps can also be observed in land areas, because in previous diagram you observe I was showing you the marine environment, or mostly the traps were under sea, but here you can see traps are possible under land area. Here is the white layer representing a reservoir, and gray layers are representing the source rock and seal rock. As I mentioned in my previous lecture, that these seals are actually the shape, and their properties varied. The if shale has enough organic material, definitely it will produce oil and gas. If shale does not contain enough organic material, or organic material is too low in that shale, then it will only act as a seal. It can't act as a source rock. So you have to be clear about the seal and source rock. And we have already talked a lot about reservoir rock, that it should be porous and permeable so that the oil and gas travel and accumulate at a particular part. Okay, here is another example. It is not necessary that your layer should be folded or make some structure, but if they are only in straight line, or you can say the deposition is straight, uh, then there is still possibility that some oil and gas will be accumulated in those traps. As you can see, here is an example of stratigraphic trap, and this dark black is actually the oil accumulated in this trap, and in the reservoir sandstone, and all this reservoir is surrounded by shale. In this particular scenario, your shale is acting as seal as well as source rock. So it can also be possible. Okay, up to this point, we have learned that there are five conditions for a commercial oil or gas accumulation. What are those? First is there must be an organic rich source rock to generate the oil or gas. Second, the source rock must have been heated sufficiently to yield its petroleum. I mean, the temperature range should be enough so that source rock can produce oil and gas or generate oil and gas. And third is there must be a reservoir to contain the expelled hydrocarbons. This reservoir must have porosity to contain the oil and permeability to permit fluid flow. So again, this third point is emphasizing the importance of porosity and permeability in reservoir rock. Fourth one is the reservoir must be sealed by an impermeable cap rock to prevent the upward escape of petroleum to the Earth's surface. And last point is source, reservoir, and seal must be arranged in such a way as to trap the petroleum. Okay. You will observe at the end of this course that most of the stuff in petroleum geology will revolve around these five conditions. We will talk about these five conditions in different ways, and we will also get some in-depth knowledge about these conditions in our later discussions. Okay, next important part, how we can explore oil and gas. There are, you can say, four stages. First stage is geological survey or geological mapping. Whatever area you have to conduct a geological survey. Means you have to develop a geological map of that area. And then after you will conduct a geophysical survey for recording a geophysical data. By using geophysical data, you will develop geophysical maps of that area. And after developing geological and geophysical maps, you will decide where to drill or where to drill a well in that area. And after drilling, you will complete a well, and if your well hit the hydrocarbon, you will get production. Okay, let's see some examples of these stages. Here is a typical example of geological map. You may have studied these in your basic physical geology or any other subject. These are contour maps of a particular area, and these types of maps are very important for defining the subsurface structure in your area and thickness of different layers and any other information that we can that is possible to extract from this map that we uh, can use for identifying the oil and gas in the subsurface. So this is a typical example of a geological map. Now next one is the something about geophysical survey, and probably you will study this subject in detail, I think in fifth semester or maybe in next semester. Yeah, you will study about this, how we conduct these geophysical surveys for identifying subsurface layers. In upper part, this is a typical example of recording a geophysical data. Hmm, Sorry. And in second image, you can observe the recorded stack, recorded sizing section, and red arrows shows the location of different layers that can be prospective for hydrocarbons. And there is a detailed interpretation steps that we will discuss in that particular subject. But for petroleum geology, you just have to take some idea what is geophysical survey and how it looks like. Okay, after geological and geophysical survey, you have to drill a well, either it is offshore or onshore. That depends on your mapping, what you got from those maps. As you can see here in red color, there is a accumulation of oil, or you can say gas is also there, and you have to reach there through drilling. After drilling, there is an important step for oil refining. Again, it is mostly relevant to geochemical or chemical engineering, but as a geological engineer, you must have a basic idea about these refining process. As the vapors gradually rise up inside in the distillation tower, they are cooled and condensed to liquid. The boiling point of the various hydrocarbons determines where in the tower this happens. The droplets that condense accumulate on trays and are fed through pipes to a collection tank. Asphalt is a mixture of very heavy hydrocarbons that form a distillate during the refining process. Okay, that you can read these basic steps. The only thing to understand is the liquid or oil and gas you obtain from the well that should be go through a distillation process so that you can separate different types of hydrocarbon like gas, naphtha, gasoline, kerosene, diesel, lubrication oil, heavy fuel oil, asphalt, and extra. Okay, here is your recommended book. I think I have shared that book in your classroom notes. So please find that book from there and let's start to read this book. And before next lecture, if you read first two chapter, that will be very helpful for your understanding of basic ideas in petroleum geology. And if you feel any difficulty in understanding some of the concepts in those first two chapters of this book, let's discuss, let's ask some questions from that, and I will try my best to answer your questions. Okay, this is end of lecture 1 part 2, and most probably it is also the end of lecture 1. And in lecture 2, hopefully I will come up with some detailed information regarding some particular topic of petroleum geology. Thank you and bye.